All right, this is section 8.2 from MathLinks 9 on solving algebraic equations in more than one step. The difference between these two-step equations and the ones you had in grade 7 and 8 is that in grade 7 and 8 you didn't deal with fractional coefficients as much, or definitely didn't do fractional equivalent values or fractional constants. So that's the addition to this. The first question says Jenna did not want to perform fraction operations to solve this particular equation. So she first multiplied both sides by 54. Is this the common multiple you would have chosen? So what we know is if you multiply both sides by a common number, in this case we can choose any number, but let's say 54, the one they use. The idea behind multiplying both sides by 54 is a basic premise of all algebra. Whatever you do to one side of an equation, if you do the same thing to the other, it maintains equality. So with Jenna, she chose 54, which is a multiple, but it's not the lowest common multiple. So if I was to look at the multiples of 2, 9, and 6, if I was to look at the multiples of those, the first one they share, if I grab my highlighter here, the first one they share is actually 18. So what she could have done is she could have multiplied both sides by 18 instead and had the same effect as if it had been multiplied both sides by 54. It just keeps your coefficients and your constants a little smaller, but it really doesn't have any effect on the procedures that you would use. It just means the numbers are going to be smaller. In question 4, it says Milo solved the 0.05x minus 0.12 equals 0.08 by multiplying both sides by 100, then solving that equation. Show how he used this method to determine the correct solution. Well, the same idea that I talked about in question 3 is that if you multiply both sides by any number, and including this one, 100, the idea of multiplying all of the terms on both sides by 100 will still maintain equality. And here, when you multiply this term by 100, you get 5x. When you multiply this term by 5 or by 100, you get 12. And when you multiply this by 100, you get this. So it does work. But with decimals, you don't really need to keep it simpler because I think when you use decimals, it's much easier because adding and subtracting decimals, you can use calculators as opposed to adding and subtracting fractions, which require a little bit more understanding of the numbers. So when it says when Milos was asked to solve the other one, he reasoned that he could do the same correctly. Uh, but the problem is when you multiply this term by 100, so let's look at it here. If I multiply it by 100, right, and we think about multiplying the tops, you get 100x. Multiplying the bottoms, you get 0.05. When I take 100, I'll bring it up here. When I take 100 and divide it by the number 0.05, I'm going to get a number larger than 5. I'm going to get 2,000. And you think about it, if I have $100 and I divide it into piles of nickels, how many nickel piles can I make with $100? The answer is 2,000. Question 5 is write an equation. So here we have paper clips representing variables. So 2 variables is equal to the, how much money is that? 50 cents, 60, I can't even see that, 70 cents, is that right? So 2 paper clips have a value of 70 cents. How much is each paper clip worth? Well, if you solve it by isolating the variable, each paper clip would be worth 35 cents. Oops, I made a mistake. It's 2 paper clips plus 15 cents is equal to 55 cents. There's a better equation. So if you had it been the other one, that's not right. So I'm going to subtract 15 cents from both sides. 2 paper clips then has the value of 40 cents. And therefore, when I isolate it, each paper clip has a value of 20 cents. Question number 6, it says model this equation, so we can use our paper clips again. So 3 paper clips plus 14 cents. Oh, we got to do 1 cent, don't we? 1 cent, 1 cent, 1 cent, and 1 cent. So 3 paper clips and 14 cents is equal to 50 cents. So that's what it would look like. Solve using your model. Well, whatever. I'm going to subtract 24 cents from both sides. That's going to leave me with 3 paper clips is equal to, that leaves me with 1 cent, 26 cents. And therefore, if I divide by 3, is that right with 26 cents? I think so, isn't it? Oh, I'm only supposed to subtract 14 here. Oh, that's 36 cents, which is divisible by 3. Then each paper clip is worth 12 cents. Don't worry about modeling those. I don't think I'm going to have that on your tests anyway. Question 7 says solve each of these questions. So we're going to solve the first one. Now, there are 2 different ways to solve this. I'm going to solve A one way. I'm going to solve B another way. So the first one, I'm going to solve it by subtracting 2 or by adding 2/5 to both sides. Adding 2/5 and subtracting 2/5 are opposite operations. I'm left with 4y equals the sum of these two, which is 5 over 5, which is 1. Then dividing both sides by 4 will tell me that y equals 0.25, or since it started in fractions, we should probably keep it as a fraction, 1/4. Now with the next question, B, keeping this idea of balance, if I multiply both sides by a common multiple of all the denominators that exist within that equation, this term's denominator is 1, so really, it doesn't really matter, but I'm looking for a common multiple of 1, 2, and 4. Now 1 I know is going to be all numbers because it's going to go forever, but 2 and 4, the first multiple they share is 4. So therefore, if I think about multiplying both sides by 4, I will create an equation that does not have a fraction, because when you multiply a fraction by a multiple of its denominator, you create a whole number. So 2d minus a half, and I'm going to put that in brackets because I'm going to multiply the entire side by 4, and 5/4 multiplied by 4. This is how I'm going to simplify it like this, and I'm going to use distributive property here. Now the first one, 4 multiplied by 2d is easy, it's 8d. And 4 multiplied by a half. Now some of you could do that in your head. You know that when you multiply a half by 4, when you multiply a half by 2, you get 1. When you multiply a half by 4, you would get 2. So the answer is minus 2, but if you didn't know that, you could simply treat your 4 as a fraction, multiply it by a negative half, and when you do so, you get negative 4 over 2, which is negative 2. And over here, you're going to multiply 5 over 4 by 4. If you cross reduce, you get a solid 5. If you didn't, you would have got 20 over 4. But either way, you're going to end up with an equivalent value of 5. Now remember, all this equation is, it's the exact same equation as up here. The only difference is the value of both sides is 4 times bigger. The value of the variable hasn't changed, but the value of the terms around it are 4 times bigger. It's still equal to each other. And now that I have that, I would add 2 to both sides. Get 8d equals 7. Divide both sides by 8, and d would equal 7/8. Question number 8, we have 1/2 is equal to 4h plus 2/3. So if I solve it the regular way, I'm going to subtract 2/3 from both sides. 4h is equal to, 1/2 is 3/2. Take away 2/3, common denominator is 6. 9/6, take away 4/6 is 5/6. Then I want to get rid of that 4 coefficient by dividing this side by 4 and taking this and dividing it by 4, which is the same thing as multiplying by the reciprocal of 4. So h is isolated, and the value is 5/24. So h is equal to 5/24. In B, we have 4/3 x, and before I get into this, you should know that 4/3 x is the same thing as 4/3 times x, which is the same thing as 4x over 3. So if this was my question, the first thing I'm going to do is I do not want necessarily that variable like that, but I'll keep it like that. Just be aware it could be the same. If I multiply both sides by a common multiple, I would multiply both sides by 12. But most of you probably did this. What's 1/2 take away 3/4? a negative quarter. And then divide both sides by the coefficient, which would be the same thing as multiplying by the reciprocal. You're going to end up with negative 3/16. Yeah. Now for question, I'm going to skip C. I'm going to go right to D. The first thing I'm going to do with D is I'm going to change it to negative 22 fifths is equal to negative 16 fifths plus 7/10 G. And I'm going to put that 7/10 G, I'm going to change it to what I told you before in the last one. I'm going to change it to this. And I'm going to do so because I am going to try and multiply both sides by a common multiple. What am I going to multiply both sides by here? The denominators in the entire equation are 5, 5, and 10. And the first multiple they share is 10. So I'm going to multiply this side by 10 and multiply this side by 10. If I multiply this side by 10 and cross reduce, what will I get for an answer? If I cross reduce that, what will I get for an answer? Negative, just negative 44. If I multiply this by 10, this first term using distributive property, and I cross reduce, what will I get for an answer there? Negative 32. And if I multiply the last term by 10, what will I get there if I cross reduce? Just 7G. So by multiplying both sides by 10, you got to really pay attention, guys, to this part right here. Pay attention to the fact that when I multiplied each side by 10, I was very careful to be able to cross-reduce the multiplication of those fractions. It made it much easier. And I took a reasonably complex equation, this one right here, and by simply multiplying it both sides by 10, I made a much simpler equation to solve. Much, much simpler equation to solve. Now all I have to do is get rid of the constant. That's going to be 8 and negative 12. Divide both sides by the coefficient. And G will equal negative 1 and 5/7. Okay, question 9. We have decimals. So for this one, we're going to subtract 2.5 from both sides. And then I'm going to multiply both sides by 0.6. And x will equal, so 10% is 35, 35 times 6. Okay, I can't do it in my head. It would be 3.5 times 0.6 equals 2.1. Is it negative or positive? It's negative. Exactly. And the last one, subtract 6.1 to get rid of your constant. 6.2, excuse me. Now, for most of us, this is a difficult one. Subtract 6.2 equals negative 5.82. And remember, when you have this written, this negative symbol can go in the numerator or the denominator. Keep it in the denominator, so r over negative 1.2. It's still a negative value for that term. And multiply both sides by negative 1.2. And r will equal 1.2 times 5.82, 698.4. That can't be right. 6.984, yeah. Positive or negative? Negative. Skip 10, skip 11, skip 12, start at 13. So 13 says the cost of a pizza is $8.50 plus $1.35 per topping. How many toppings How many toppings are on a pizza? So once I read that my question says how many toppings, the first thing I'm going to do is define my variable as x equals number of toppings. Because I don't know it, and I need to solve for it. So the number of toppings is going to be my variable x. If it's $8.50 for the pizza, regardless of how many toppings I have, that is going to be a constant term. And $1.35 per topping means I'm going to take my number of toppings and multiply it by $1.35. This algebraic term here will represent how much money you will spend on toppings. Plus you will spend $8.50 for the pizza. And overall, if the pizza costs you $13.90, using this equation, you'll be able to isolate the variable to determine how many toppings you bought. Subtract the cost of the pizza from both sides. The cost of your toppings will equal $4.40. No, $5.40. Then divide both sides by the cost of your topping. And x will equal 4. Therefore, how many toppings did you had? You had ordered a pizza with 4 toppings. So this question is almost exactly the same as the pizza topping question that we just did, except it says this time it's the constant term of regardless of how far he drove, it's this much money, plus 12 cents per kilometer he drove. And if the rental cost was this much money, how far did you drive? So the first thing we're going to say is how far means x is going to equal how far he drove or how many kilometers he used, how many kms. First thing I always do in my story problems is find my variable. If it's 12 cents for each kilometer, then the algebraic term would be taking 12 cents and multiplying it by the number of kilometers you drove. So the algebraic term, 0.12x, will represent the cost of his mileage, plus the rental fee of the car. Both of these combined came in at a total price of $55.11. Subtract the cost of the car rental to get just the cost of the mileage. And the cost of your mileage will equal $55.11. Take away $34.95. 2016. So if I divide both sides by the 12 cents, x will equal 2016 divided by 12 equals 168. Is that right? So therefore, he drove 168 kilometers.